Welcome to Spring LIB.
In this exercise, we're going to be talking about circular motion. So before actually solving the problem, I'm going to briefly review the topic. So when we're talking about a circular motion, we have a particle that undergoes a circular trajectory, and the acceleration of this particle can be decomposed into two components. The first one is radial, meaning that it points towards the center of the circle of the trajectory, and this is called the centripetal acceleration. And we also have the tangential acceleration that is tangential to the curve. Okay, and we have that the centripetal acceleration is equal to v squared over r. V is the speed of the particle, while r is the radius of the orbit, while the tangential acceleration is equal to the derivative of the speed with respect to time. So the centripetal acceleration is all about changes in the direction of the velocity, while even if the velocity, even if the speed remains the same, while the tangential acceleration is all about the changes in the speed, that is, the changes in the magnitude of the velocity. So this is the information we need in order to solve the exercise. So what we have is a boy that is in a swing. The boy has a mass of 60 pounds and initially makes an angle theta with a horizontal of 60 degrees as shown in the picture. The length of the wire that connects the swing to the center of rotation is 10 feet, and the initial speed of the boy is 0 meters per second. So instantaneously at theta 0 equals 60 degrees, the speed is 0. And our goal is to use this information in order to find what is the speed of the boy when theta is equal to 90 degrees. Okay. And also, we need to find what is the tension on each cable of the swing at the same instant. So remember that the swing is composed of two cables, each one with a tension T. Okay, so in order to solve this, we need to draw a force diagram on the boy. So here we have the boy, represented by this black circle. We have the tension force acting in the direction of the swing, and the force is equal to 2 times the individual tension of each cable. We also have the gravitational force acting downwards. And this is all we have. Now notice that we can decompose this force, decompose the forces into two components. One that is centripetal, that is the point in the direction of the center of rotation, and the other one that is radial. Okay. Also, notice that this angle here is equal to theta. Okay, because this angle here is equal to theta. So in the centripetal direction, which I'm going to call R, we have 2t minus mg times the sine of theta, and this is equal to m times the centripetal acceleration, which is v squared over r. In the tangential direction, we have 0 plus mg times cosine of theta, and this is equal to m times the tangential acceleration. So I'm going to take the equation for theta and find that the tangential acceleration is g times cosine of theta. Now notice that the tangential acceleration is equal to dv dt. Okay? And this is g cosine of theta. So we have that dv is equal to we have g cosine of theta times dt. Now I'm going to multiply both sides by v, so we have v dv is equal to v g cosine of theta dt, and I'm going to substitute v in the right hand side by dx dt. And x is the element of arc length along the element of arc length of the circle. Okay, this is the x times v cosine of theta dt. So the dt is canceled out. So we have that v dv is equal to g cosine of theta times dx. Now we can associate the element of arc length with the element of angle by the formula r d theta. So we have v dv is equal to g cosine of theta r d theta. Now I'm going to integrate from the speed when theta is equal to 60 degrees, which is 0, to the speed when theta is equal to 90 degrees, which is just v. So we have that v squared over 2 is equal to rg times sine of theta from 90 to 60. So v is equal to the square root of 2 times r times g times 1 minus the square root of 3 over 2. So v is the square root of 2 times r, that's in feet, that's the radius of the trajectory, times 9.8 meters per actually, let me write it in feet per second squared, so 32.2 feet per second squared, times 1 minus the square root of 3 over 2, and this is equal to 9.29 feet per second. Okay, this is the speed, and now we have to find the tension. So I'm going to use the equation for the r coordinate here. We have, I'm just going to copy it down here. So we have 2t minus mg sine theta is mv squared over r. So t is equal to m over 2 g times the sine of theta, and we're interested in the tension when theta is equal to 90, so the sine of 90 is just 1, so I'm not going to include the sign here because it would be the same as multiplying g by 1 plus v squared over r. So t is equal to 60 pounds divided by 2 times g, that's 32.2 feet per second squared, plus v, which we found to be 9.29 feet per second, divided by r, and that's 10 feet. And now I'm going to divide it by 32.2 pound feet per second squared per pound force. So T is equal to 38 pounds, 38 pound force, which concludes our exercise.